Hello, Dr. Arthur D. Kemp, the Hammond Doc. I'm working on a Hammond AO28 preamplifier. And a gentleman by the name of, who goes by BRY on YouTube asked me, he said, please make a video on restoring this amp or replacing all the bad parts. Thanks. Okay, so I'm going to do that for you, BRY. And so I'll make a series of videos as I progress on this preamp rebuild process or refurbishment process. I've already made the first video, deals with my first step, which is cleaning the amplifier chassis. So I've done some preliminary cleaning. I'll also do some cleaning of the undercarriage here as well. But the next thing I like to do is begin assessing components on this side of the amplifier, of the preamp. Okay, so I have my multimeter. This is a Fluke 289. Very precise instrument for measuring the values of internal components and a vintage amplifier. And I have clips on the ends of these here, see? And I have the clips clipped to a resistor. In fact, this is a 1 ohm resistor that I have this clip to. And I've already tested this thing, but because you asked me to make the video, I'm just going back and I'll show you what I did. VRY. All right. So the clips are on the resistor now, and I have my meter set. This particular resistor, according to the color code, is a 1 meg resistor and 1 mega ohm resistor, and so that's what I would look for on the meter. But you see what I'm getting on the meter is 6 mega ohms, 6.53 mega ohms, which means that this particular resistor is way outside of the range of tolerance, and therefore it will be removed. Now, I don't remove the components right then. What I do is continue to do my testing of resistors and the capacitors. I come back and do a capacitor, and then I'll mark them. So if you can see this yellow tape right here, I've written down 1 meg on the tape, and I put the tape across that particular resistor, and I'll do that throughout this entire preamp. So when I'm finished my evaluation process, there'll be yellow tape all along this side and all along this side, and that'll be demarcating all of the bad components. Then once I've identified all the bad components, all the bad capacitors, all the bad resistors or resistors and capacitors, I'll then go back and start cutting them out and replacing them. So that's my procedure. And of course there are things like this that I'll cut that out and replace that with the appropriate can anyway. Here's a couple of caps that I always replace. This side here, these are for my vibrato, so I always replace these two. These two get replaced, as well as these two, which deal with percussion. You can see that. So I always replace these two and these. And because if you ever own a Hammond organ, if you've ever hit the switch and you hear boom, for percussion it goes boom or pop, there's a heavy pop, it's because these need to be replaced. And for or for percussion, it's because these need to be replaced. And then for vibrato, you hit the switch and it gets pop, boom. This is for the vibrato side. This and this is percussion. It's because these are bad. You hear that pop. It's passing DC voltage, DC current coming through these capacitors. So that's why you hear that loud pop. So I always replace those. I want to show you. I'll come back. I'll make another video and come back and show you my testing of this, because it's important. There's something important that I want to share with you with regard to testing these electrolytic caps. Here's one, of course, I've already marked it, and I marked this one too, but for a particular reason. So I'll come back. I'll make another video where I come back and explain why I marked this. All right. So until then, this is Dr. Kemp, the Hammond Doc, saying to you, peace out. Thank you for watching the videos, by the way. All right, brother. BRY. Peace out.